Going to start lesson 10.3 today on multiplying polynomials. Um, we're going to begin primarily working with a binomial times a binomial and how we go ahead and multiply those two together. And then we'll work in a little bit more complex versions of that. But let's take a look at what we're talking about here. When we multiply binomials together, so a binomial times a binomial, we have to use this process that's called FOIL. All right, and FOIL is an acronym, uh, and the letters of FOIL represent the order in which we multiply these two binomials together. So the F in FOIL says take the first terms in each parenthesis and multiply those two together. The O says multiply the two outer terms together. The I means multiply the two inner terms together, and then the L says multiply the last term in each parenthesis together. Okay, so the FOIL method is telling you the process of multiplication that you need to go through to multiply the two binomials together. So let's look at this here. So we have two binomials being multiplied together. Notice they're next to each other. That indicates multiplication. Okay, so what we have to do now to go ahead and multiply these together is apply this process of FOIL. Okay, so in the FOIL, we're going to multiply the firsts terms together. So that's the term that's first in each of the parentheses, multiplying them together first. So the F stands for, in this case, Z times Z. Okay, and then we'll do the O, which is the outside two, so the outer two. So be careful with signs here. This is going to be now plus Z times negative 12. Okay, that minus in front of that 12 makes that a negative 12. Of course, that minus in front of the 6 makes it a negative 6. But the O is for outside, so that's Z times negative 12. The I represents the inner two, so this is going to be negative 6 times Z. And then the L stands for the lasts, so we're going to multiply negative 6 times negative 12. Okay, so the F, the O, the I, the L all represent products. And the next step in the process is to simplify each of those products and then see where we're at. So, okay, if we go ahead and do that, the F, which was Z times Z, is Z squared. The O is Z times negative 12. That's negative 12Z or minus 12Z. The I was negative 6 times Z, so that's negative 6Z. And then the L represented negative 6 times negative 12. That's positive 72. And then the last thing we always need to do is to write it in standard form, which means combine any like terms. So the like terms here, so we have four terms, right? Z squared, negative 12Z, negative 6Z, and 72. The negative 12Z and negative 6Z are what we call like terms because they're the same variable to the same power. So we can combine those two. And our final answer is Z squared minus 18Z plus 72. So this is our simplified answer. Now, the reason we really emphasize multiplying these binomials together is because pretty soon you're going to be given a statement that looks like this trinomial right here, and you're going to figure out what two binomials could we multiply together to get this answer. And that's a whole process coming down the line, but that's kind of how we're working it right now. So we're going to work on multiplying binomials together here first. That's our answer, okay? So let's go ahead and practice that. So we're going to multiply these two binomials together. It's all about FOIL. So it's going to be first 3x times 4x. It's going to be outsides 3x times 10. Inside negative 4 times 4x. And then lasts negative 4 times 10. Okay, simplify each of those products. Okay, we're going to get 3 times 4 is 12x squared, plus 3 times 10 is 30x, plus negative 4 times 4 is negative 16x, plus negative 4 times 10 is negative 40. My middle two terms here are like terms, so 30 and negative 16, that'll give me positive 14x. Again, you combine the numbers, so it's 30 minus 16 is 14, keep the common term x. So there's our simplified answer. Now, one thing you notice when I use the arrows this time is another way to look at multiplying two binomials together. And when we do our next one, I'm going to talk in that term, the terms of how I did that. So when you notice here, if you look at the FOIL process, what it really is distributing the first term through this parenthesis and then distributing the second term through this parenthesis. Okay, it's the same thing as FOIL. Let me show you what I'm talking about. So negative 5p times 2p is the f in FOIL, but it's this first term times this first term, right? The O is the outside, which is really negative 5p times the second term. So I took negative 5p times the first, then negative 5p times the second. The I is inside, which is now the negative 9 times 2p. And then the L, or the last, which is negative 9 times 6. So in essence, what we really did was took the negative 5p and multiplied it by each of these. That's the F and the O. Then we took the negative 9 and multiplied by each term here, and that was the I and the L. So it's really distributing, but we can say FOIL as well. All right, so same concept here. Let's simplify each term. We're going to get negative 5p times 2p is negative 10p squared. Negative 5p times 6 is negative 30p. Negative 9 times 2p is negative 18p. And then negative 9 times 6 is negative 54. Okay, combine our like terms, which are these middle two terms, are like terms. And we're going to get negative 10p squared minus 48 minus 54. Okay, there's our final answer. So pretty straightforward. Okay, an application of this, ignore this right here because it's the answer, is, this is a common question too. So this town worker's clearing snow from this parking lot and the surrounding sidewalk. So this outside gray here is the surrounding sidewalk. We're supposed to, the sidewalk is X feet on every side. So this distance of X is the same as this distance. And this side is X, and the top here, this distance is X also. All right, so we're supposed to write an expression to represent the area of the parking lot and the sidewalk all together. Okay, so area is, since we're dealing with this rectangle here, area is length times width. Okay, so we got to represent our length and represent our width and then multiply those two together. Well, the length of this entire parking lot, I'm going to talk about this as being the length, okay, is we would go X, then 60, and then another X. So the overall length of this entire parking lot would be 2X plus 60. X is 2X plus 60, the distance across. The width, I'm calling this the width here, is going to go X units, 70, and then X. So the full length here is going to be 2X plus 70. So I've represented the length with 2X plus 60 and the width with 2X plus 70. And to find area, I got to multiply length times width. That's a binomial times a binomial. So we need to FOIL. All right. So, we generated our two binomials by looking at the drawing and understanding that area is length times width. And now it's a FOIL process. So first, 2X times 2X. Outers, 2X times 70. Inners, 60 times 2X. Last, 60 times 70. Okay, remember it's also like distributing the first term through the parenthesis and then the second term through the parenthesis. Okay, now multiply each product here together and simplify that. We get 4x squared plus 140x plus 120x plus 4,200. Combine our like terms to write our answer in standard form. 4x squared plus 2x plus 4,200 is the expression that represents the area. So I put here the total area of the parking lot is 4x squared plus 260x plus 4,200. And then what you can do is, and so if the sidewalk was, let's say, 3 feet wide, I could put 3 in place of this X, 3 in the place of this X, solve this, and it will tell me the total area if the sidewalk is 3 feet wide. Now, if the sidewalk was 4 feet wide, I could put a 4 in place of this X, a 4 in place of this X, solve all this, and that would tell me what the area would be if the sidewalks were 4 feet wide. So it allows that, it's kind of like a formula now that allows us to, whatever the width of the sidewalk is, plug it in and get area. Okay, so that's that. The last thing I want to show you is multiplying conjugates. Okay, all right, so conjugates are in the form of a binomial, and a math conjugate is formed by changing the sign between the two terms in a binomial. Okay. So for instance, if I had the binomial x plus y, its conjugate would be x minus y. So the terms are the same, xy, xy. The difference is this is plus, this is minus. Those are conjugates. Okay, we also just say that, x plus y is the conjugate of x minus y. Now we talk about conjugates specifically because of what happens when you multiply them together. So here's a set of conjugates: 2n plus 7, 2n minus 7. The terms are the same, 2n 7, 2n 7. The difference is this is plus, this is minus. Okay, so let me show you what happens when you multiply these two together. Okay, so firsts, 2n times 2n, outers, 2n times negative 7, inners, 7 times 2n, lasts, 7 times negative 7. Simplify each product. 4n squared, negative 14n, positive 14n, negative 49. Now, the key to this whole thing, conjugates, the reason we talk about it is because what happens with these two middle terms, your like terms are always going to be opposites of each other. Since they're opposites, they cancel each other out, and you're left with the answer of 4n squared minus 49 in this case. Now, notice that my answer became a binomial. It had been a trinomial, the first several examples I showed you. So you will get answers sometimes that are binomials if you multiply using conjugates. Okay. Also, remember how I said that at one point in time here, we're going to take this and try to go back to this direction. So if I give you this, what's this binomial? What are these conjugates? Okay. So what you got to see here is that this is actually a difference of two squares. Okay. This is 2n squared, which is your first term, difference minus, and this is the 7 squared, which is your second term. Okay. If you mess around with these a little bit, write out some different conjugates and multiply them together and look at your answers, you'll start to see a pattern to this part of it. All right. And that's where we'll get to eventually. Okay. So that's all we're going to do on multiplying polynomials today. We're going to focus on binomials, looking at different variations of questions that deal with those. All right. So review this as you need to, and I'll let you get started on your work.